Thank you for your attention. We will start our presentation right now.
Our topic is about translation device for patients with dysaria. Here is the content page. Dysaria is a condition that patients are unable to communicate with others because of neurological disease. These patients may still possess a normal cognitive function. Our invention is designed as a real-time language translation device allowing these patients to speak. Currently existing translation device for this patient is an on-screen keyboard, but slow and inefficient. Therefore, we want to develop a new model of translation device consists of AI, EEG amplifier, and human voice synchronizer. The ideal properties of the device is pocket-sized with several lists of EEG attached to the patient's head. We hope the invention eventually increase patients' quality of life physiologically and psychologically. Various disorders will result dysaria such as stroke, traumatic brain injury, Parkinson's disease, and amyotrophic lateral sclerosis. Here is the prevalence, and you can find it is a common problem. From the literature, the past invention allow patients to select letters and put the words on the screen of computer. However, the device requires patient training and communicates in a slow way of 1 word per minute. Recent development can achieve faster communication rate but still heavily relies on spelling approach, which is inconvenient. Our study aims to address the limitations of the past inventions with newly developed technologies and achieve communication by the motor speaking imaginary. For the study design, we need to develop an AI to analyze and decode the EEG. Dysaria patients will be required via the internet or in the hospitals. The participants will provide data of their EEG to develop the AI. Once the prototype of the AI is completed, the device will be further tested on dysaria patients to ensure the accuracy of the translation and the performance of the human voice synchronizer. A control of the brain-computer interface with spelling approach will be used to determine the accuracy of the translation device.
And for the mechanism of the invention, we will have another group mate to explain with.
For the mechanism of the invention, we will talk about the nature of the electroencephalography, the EEG, capture of signal in the brain, analyzation of the signal, translation to sign, and the comparison between new model and the old one. First, for the nature of the EEG, it is a electrophysiological non-invasive monitoring technique to record the electrical activity inside the human brain. By placing the electrode along the square, the electrocorticography can be detected changes the voltage of the electrodes. Neurons in the brain stimulate nerve impulse will create changes of voltage, and the EEG can record the voltage difference between different electrode points. There are billions of neurons inside our brain. In the process of neuron transmission, neurons will be polarized to pump ions across other membranes. Ions of similar charge will repel others. Once there are many ions pushing together, it will produce an electrical wave. Next, for the capture of a signal in the brain, our cerebral cortex can be divided into 4 parts. First, the parietal lobe, the temporal lobe, occipital lobe, and the frontal lobe. Frontal lobe is responsible for receiving and generation of signals, including sensation identifications, motor functions, cognitive thinking process, and the language processing. There is a dual auditory pathway connecting the auditory cortex and the frontal lobe in the brain. The auditory ventral stream, auditory dorsal stream, they are both responsible for speech formation in the brain. The auditory ventral stream connects the auditory cortex via temporal pulse. It is responsible for sentence comprehension. On the other hand, the auditory dorsal stream connects the auditory cortex via parietal lobe. It is responsible for speech productions, particularly for vocal expression of words. While making use of the EEG, electrode placings will focus on the anterior parts of the brain as frontal lobe is responsible for language processing.
For the analyzation of signal, I will explain about it.
For the analyzation of signal, we will use Alter Ego, an invention of MIT student, assists in brain signal analysis. It can transfer the signal into wordings. And the translation to sound will use the translation device, and this device will choose appropriate wordings to speak out after analyzation. Our translation device will cooperate with Google Translate to build up the translated sentence. At the beginning, our device will only contain the Cantonese and English version in the language database. So the actual mechanism of our translation to sound is applying the electromechanical transducer to convert electrical signal into sound waves. That is a voice coil inside the electromechanical transducer, and the wire of voice coil is suspended in a circular gate between the poles of a permanent magnet. The voice coil will be forced to move due to Faraday's law of induction when there is a current electrical audio signal passing through, and causes the diaphragm coil to move and push air to create sound waves. So this is the mechanism of the translation to sound. Another thing I would like to share about is the comparison between new model and the old one of the FOSS device. So the old model have quite a lot of drawbacks. First, it requires certain hours of training of the users, and it is no efficiency of word testing and expression, and they need to detect the brain signal for minutes. And for our new model, there is no training required to use in this device, and thoughts and expression are sequences and transfer the signal into wordings almost in real time and instantly.
So for the participants in the study, we will explained by another groupmates.
Then we will come to the part of invitation of the participants. We will invite the participants with dysaphasia under normal conscious status, and the inclusion criteria will be normal conscious status, can follow the researcher instruction for eye movement, conscious EEG readings can be detected, and the normal brain image results. And then we come to the ethical consideration part. We will first obtain the approval from the Donghua College Research Committee and the Research Ethics Subcommittees. The implied consent form will be received from participants before enrollment under the witness of both researchers and participants' family. Participants and their family can refuse to continue the experiments voluntarily and at any time. Also, the details of information shared will be read to the participants and ensure them approve the study, and the sheets will be also given to the participants' family. All data will be kept confidentially until for 1 year, and only the researcher can attach it. And then we come to the ethical risk part, and there is a ethical risk of privacy problem, because due to the properties of the fourth translation device, clients do not have the expression their ideas through speaking, but only generate idea in their mind. There is a privacy consideration that clients' ideas are being captured and recorded by the machine without permission, and possible risk of data disclosure to others. Also, the device might express some secret idea which the client do not want to speak out, but the ideas are captured. But it is noticed that all ideas and data from subjects in such research only will be kept confidentially and for academic use. And we will also talk about the resources required. And Chinese data collectors will be employed for the data collection of full translation device, as our team will analyze the collected data, so there is no need of employer the analyzer. And Chinese EEG device is needed in the study, and also the approval of using LTE ecosystem is also needed. And then finally, this is our reference. Thank you.
Thank you. This is the end of our presentation.